Hey, in this video, I'll walk you through everything you need to know about the Model Context Protocol or MCP. You'll go from understanding what MCP is, how it works under the hood, to building it from scratch and integrating Claude with both ready-made and custom MCP servers. We'll start with a clear explanation of what MCP is and why it matters. We'll then dive into how it works in depth, breaking down its core concepts and architecture. And to enhance our in-depth understanding, we'll implement the MCP protocol from the ground up, not just spinning up the MCP server, but the full system that connects to tools and invokes them. You'll see exactly how MCP orchestrates tool selection based on user input, passes the right parameters, and returns results, giving you the deep insight needed to confidently work with, debug, and extend MCP systems rather than treating them as a black box. After that, we'll move to the practical side, integrating MCP servers with Claude using a ready-made server. We'll integrate a ready-made web crawling and search MCP server from Decodo with Claude, giving the LLM the ability to retrieve data and information from websites when responding to questions. And finally, I'll show you how to build your own custom MCP server and connect it with Claude as well. Decodo is this video's sponsor, and they provided a 7-day free trial for you guys to do the hands-on practical project completely for free. They provide awesome web scraping and proxy services that are reliable, fast, and ethical. So make sure to check them out in the description below. This video is your complete guide from theory to real-world application. So, let's get started. MCP or Model Context Protocol is a standard way for LLMs to utilize external tools and data sources. An LLM can only generate and understand text, but external tools give the LLM capabilities beyond that, like how ChatGPT can now browse the internet to find real-time information using the search tool, or create images on the fly with the image generation tool. Those tools are increasing more and more, giving the LLM the ability to send emails, manage calendars, provide app automations, and way more. Technically, an LLM can interact with tools even without MCP. But without a standard, every developer has to write their own custom glue code to make their tools work. That leads to inconsistency and a lot of unnecessary pain for developers and users. The adoption of such tools will not be plug and play, rather require some setup to make it work and to maintain. To highlight this pain, let's take an example of a standard method we are all familiar with, HTTP. HTTP is a protocol that web browsers use to request web pages. You've probably seen it in URLs like https www.google.com. Because of this standard, you have the ability to get any web page on the internet just by writing its URL, and the web browser will use the same protocol to get all web pages that you request. Now, a world without HTTP, where every website would send its data differently, you'd need to tweak the browser settings, rendering logic, or even install special plugins just to access each website you visit. Imagine how painful and inconvenient this would be. This is even worse when integrating tools for LLMs. MCP solves this by defining a standard interface for tools to connect to LLMs. This way, we can connect to all tools in the same way, making the integration reliable, easy, scalable, and without much fidgeting to make it work. To understand how MCP works, let's take a closer look at its main building blocks. MCP consists of three main parts: the host, the client, and the server. The host provides the environment and the GUI for the AI application. It's also the place where the LLM is loaded and where the final user response is generated. The MCP servers are tools or data sources that the LLM can utilize to extend its capabilities. They provide functions like accessing files, calling APIs, and running code that do certain tasks. Those tools can run locally or remotely. A lot of companies are creating their own MCP servers right now that do a lot of interesting functions. Here are some examples. The Calendar MCP by Zapier, where it allows you to get the calendar events and even get its details. Another good one is the Puppeteer MCP server, where it provides browser automation capabilities through a tool called Puppeteer. Another awesome MCP is Decodo's web scraping and search MCP server. This MCP lets you crawl the contents of any website, enriching the LLM with data and information it didn't know. It also searches Google and Amazon and returns back relevant data and information relevant to your prompt and questions. We will be integrating Decodo's MCP server with Claude in a hands-on practical tutorial. And since Decodo sponsored this video, they provided a free trial that you guys can use to do this tutorial completely for free. So make sure to check them out in the link in the description below. There are three types of MCP servers or tools: the resource capability, the tools capability, and the prompt capability. The resource capability is an MCP server that returns back data or information needed to respond to a user prompt that the LLM did not already know. For example, an LLM might already know what is the fastest animal on the planet, but it doesn't know what is the GPA of a specific student. So, it will rely on a tool to query this data from the university database and respond back to the user. The second capability is the tools capability. This allows the LLM to carry on tasks that the LLM can't usually do. Since the LLM is just capable of generating text, if you asked it to send an email, it won't carry out the operation. It only can respond with some text telling you how to send the email, but if you connect a tool that sends emails, the LLM can go trigger this tool and give it the necessary input to send the email. The last capability is the prompt capability, and here it edits the prompt to a specific structure best suited for a task. Last but not least is the client, which acts as the bridge between the host and the servers. When a user sends a message, the client helps decide whether any external tools or servers are needed to fulfill the request. If so, the client sends the necessary input to the right server, waits for the result, and passes it back to the host. This allows the host to do tasks and to generate smarter responses using the external context provided by those tools. Let's see how a user prompt flows through an MCP structure. The user sends a prompt to the MCP host. Then, the MCP client, based on the LLM's analysis, chooses the relevant MCP servers. Then, the client invokes external tools or APIs exposed by the server, passing any required parameters. Then, the MCP server executes the requested operations and returns the results to the client. Finally, the client relays the results back to the host, which then formulates the final response for the user. We will develop all three parts of the MCP from scratch, and this will allow us to understand it in detail and not only take it as a black box. We will do it step by step in a Collab notebook so that you can follow along and play around with the code. Before working in our MCP code, we need to set up our coding environment so that it can load an LLM and we can give it prompts and it can respond back to us. I'll give you the option to work with two different models. One, the Hugging Face Llama model, which is going to be completely for free, and we are going to run it on the GPU for Google Colab. And the second one is OpenAI API. You can pick either one, but I will continue the tutorial with the Llama one. But I'll set up both so that if you want to work with OpenAI, you can feel free to do so. So let's go to Google Colab. You can write in Google like Google Colab like this. Press on the first one just to see. We can create a new notebook right there. Let's call this notebook MCP. And don't forget to change the runtime to a GPU runtime. So from here, press this runtime, change runtime type, and press this T4 GPU, and then save it. So let's now go to get our Hugging Face Llama model. So you can go back to Google. You can write here Llama Hugging Face, and you're gonna find here like huggingface.co/meta llama. This is the page where all llama models reside. So first, make sure to log in. It's completely for free. So if you don't have an account, just create an account. It's completely for free. And then go to this Meta Llama page. And then the model that I am going to choose is 3.2 3 billion parameter instruct. Now 3 billion parameter is good enough for us, and it's going to be loaded easily into the Google Colab. So you can go to this models, you can press view more, and you can just find the 3.23 billion parameter instruct. So let's scroll. So it's going to be this one. So Llama 3.2 3 billion parameter instruct. So you need to accept its terms of use so that you can get access to utilize it. So from here, I will show you how it looks. So just copy it. I will show you here how it looks if you don't have access. So you will need to have this, and you'll get this, and you'll need to log in. And after you log in, you'll have a button right there to say grant me access. You just click it, and yeah, you might need to fill in a couple of information. So just fill it, and you'll need to wait 5 minutes or something, and then you will have this right there. Gated model, you have been granted access to this model. Now, once you're granted access, you can go back to your profile. So press on settings, then go to access tokens, and you can see that you don't have any access tokens right now. So you can just create new token, make it right, and you can just name it MCP token. And here is the token. So just copy it, return back to your Google Colab, paste it right in. And also, while we're at it, just go back here and let's paste in the, just copy the name of the model. So come here and paste it right in. And to load it, you can have the imports. So just have a imports like here. Like this, then import torch, then from transformers, we need to import the O2 tokenizer, O2 model for casual LLM, and also pipeline. And let's import also the Hugging Face hub, and let's lastly import JSON. Now after this, we can just load the model. So let's load model, and then we can have the model name, which is going to be equal this, which we copied. By the way, this here is the model names for all Hugging Face models. So make sure to copy it and yeah, to utilize any Hugging Face model. If you're feeling lost about how to use LLMs and the LLMs in code and things like that, and what are Hugging Face, I'll leave also a video in the description below that is going to introduce you about LLMs and introduce you how to use them and how to prompt engineer it also. With that being said, right now you can also follow along with this quite easily. We will just need to like import it, and you'll find like utilizing these models is as simple as writing a prompt. So yeah, just the like setup part where we like load the model from the Hugging Face is going to be a little bit tricky, but hopefully it's just like a couple of lines of code. So yeah, you can take it as is to load the model. So from here, let's have the torch dot random dot manual seed is going to be equal 0. This is because if there's any randomness, I want you to get the same results that I am getting. So we are also going to load in the Llama model. So To load it, we use the auto model for casual LLMs like this, and we call from pre-trained, so from pre-trained, and we can give it the model name. We can give it the device map, which is going to be equal CUDA to run on GPU. Then we are going to have the torch. D type is going to be equal auto, and trust remote code is going to be equal to true. Now this is how to load the model. Let's also load the tokenizer. So the tokenizer equal auto tokenizer from pre-trained, give it the model name, and you can just delete the last part. And from the tokenizer right there, we can add the padding token. Since padding token here is not initialized, we are going to just give it the same token as the end of sentence token. And last but not least is to define a pipeline where it tokenizes the text and then it runs the model. By the way, tokenization is the process of changing the words or subwords into like numbers so that the model can process it. And here, this is how you can initialize it. Again, I go into more details into the video that I linked below. So if you want to check it out, feel free to do so. But yeah, again, you don't need it here. We need to understand MCPs here. So in here, we are going to have a pipeline. The task is going to be text generation. The model is going to be the model that we loaded above. The tokenizer is also going to be the tokenizer loaded above, and we can delete the rest. So from here, we can just run it. And yeah, it tells you here that this model needs access. So that's why we copied our token. So in here, we can have the Hugging Face Hub dot log in and give it the token that we copied. Awesome. Then we run it again. It will take a little bit of time to load, so I'll cut the video and return back when it's done. So right now it finished loading the model, so let's utilize it. We can ask it anything as normal as we can ask ChatGPT. So let's say that we are going to have messages, and this is the list of messages that are back and forth between the user and the prompt and the LLM itself. So let's say we want to ask about, can you provide instructions on how to create a cake. And this is going to be a list of messages between the user. We can also make it the assistant. We can give it the assistant responses, or we can have something called system prompt that I will go over it very soon. And then we can have the generation arguments. So the generation args is going to be we can define max new tokens, which is going to be 2000. So this is the maximum number of tokens that the LLM can return for us. Return full text is going to be equal false. Full text is going to return basically both the question and the answer into one response. We just want the answer, so we just made it to false. And do sample is going to be equal false. Do sample is going to be equal false. So basically, sampling is just a little bit of randomness between the responses. So if you asked anything to ChatGPT, for example, a question multiple times, you're going to get a different response every time. And this is due to sampling or something called temperature. And the temperature is a number between 0 to 1. And the closer to 1 to it, the more randomness it's going to generate. And yeah, just to run the model, we are going to have the pipe. We are going to give it the list of messages, and we are going to give it the generation arguments. The last thing is going to be printing out the output, but let's run it first. So in here, let's print out the output and see what's inside. So you're going to see that it's a list, and basically from this list we just want to get the 0, and inside of the list you're going to find the generated text as one of the keys to a dictionary. So let's also choose that, as this has the response that we want. So you can just choose it and print it out, and you can see here that it lists out the ingredients, which is flour, baking powder, salt, whatever, and then tells you the instructions step by step. And this is just a normal chat right now. So you can go back and forth, ask it whatever you want, as if you're using a normal chat GPT. And for that, we just want to put this code into a convenience function so that we can just call it whenever we want. So we are going to have a part called response function, and in here we are going to call it define get response, like this, from messages, and it's going to be Hugging Face. And in here we are going to give it the pipe, the messages, the temperature. Again, temperature is the amount of randomness, temperature, and we are going to make it 0 at the beginning. We don't want any randomness. And the sampling, which is the do sample flag right there. If it's going to be 0, then there is no sampling at all. If it's going to be more than that, we are going to basically make that sampling is equal to true. So it's going to be false if temperature is equal to 0, else it's going to be true. Then we can just copy paste this. So copy paste it right there, and make sure to do the sampling with the do sample with the sampling flag that we initiated above. And if the temperature, so if temperature is not equal to 0, then we are going to set up the temperature and put it. Otherwise, we are going to get the output, run the model, get the output, and return back the generated text. So let's try it out. So in here, we are going to define a list of messages, and let's copy paste our user message, which is like just wanting to make a cake. And yeah, just put it right here. And let's define another role. This is called the system prompt. So the system prompt is the prompt that like tells the LLM the context of this conversation and who this LLM is in this exact conversation. So in here, for the content of this system prompt, which basically defines the context of the LLM here in this conversation and tells it who it is. So basically we can just have it something like, you are a helpful AI assistant. And again, it's a helpful AI assistant from the beginning, so it shouldn't change the output that much. But I just wanted to introduce what are system prompts, and you can actually like put here, you are a sports analytics, you are a a classification bot, whatever you want. So it defines the role of the LLM itself in this conversation, and it acts as such. So from here, we can get the output, which is get response from Hugging Face, messages from Hugging Face, give it the pipe, give it the messages, and then it returns back the output. We can print it out and see the results. Awesome. So this is it, and it actually generated the same output or very close to it. And yeah, you can see here that we can utilize it quite easily. So this is the function that we are going to use in the remaining of the code, but also I want to show you how to utilize OpenAI. We are going to create a very similar function to it, so that if you want to use this function or the OpenAI's function, you have the ability to do so. Just remember, this Hugging Face one is completely for free, so that's why I am going to use the Hugging Face one. OpenAI one gives you free credits, like $5 of credit, but it depends whether OpenAI would give it in the future or not. So that's why I am relying more on Hugging Face. So let's create a section called OpenAI, and let's now get our tokens, get our credentials, and build our OpenAI model. So again, go back to Google, and if you don't have OpenAI, an OpenAI account already, just go to OpenAI platform, create an account. It might ask you to give your phone number and things like that, but it should be completely for free. And then you can here get the OpenAI settings. So right here, this is the OpenAI platform settings. You can go to it by having the https://platform.openai.com/settings. Here, you're going to find a lot of good things, but we are going to be focusing on the API keys. And also, when you create an account, it might give you a $5 worth of credit. So make sure that you go to billings, and if there is a place where you can redeem this, so feel free to redeem it to make this tutorial completely for free. If not, then move along with the Hugging Face option that I already showed you. But from here, the OpenAI, go to API keys, then press on create new account. You can create a key called MCP tutorial, and you can just select whatever thing you want, whatever project, then create key. Again, just copy this key. You have the key up here and ready, but again, make sure that you have enough billings for it, or like the money for it, either with credits or you put some money into it. So go back again to your code, and from here, right from OpenAI, import OpenAI, and we want to create the OpenAI client, OpenAI client, which is going to be OpenAI, and give it API key. Also give it the token that you just copied from the OpenAI website, and run it. Again, very similar to our Hugging Face one, we will create a messages. And in this messages, we would have the list of messages where we have the role, and we are going to delete the system prompt. But for the user prompt, we can make something that is very simple. So let's ask it, what's the capital of France? And to get the output from the messages, you can have the output is equal to OpenAI client.chatCompletions.create. Give it what model that you want to use. I am going to use GPT-4o and Mini. And yeah, we can just give it the list of messages, and we can keep the temperature as default and everything else as default. So just run it, print the output. You can see the output here. It has chat completions. If you scroll more, you're gonna find the it has the message, chat completions, and then content, and then this is the final output of the LLM. The capital of France is Paris. So let's print this out. So print output dot choices of 0, because it has choices and it's a list of choices. So choices right there. It has a list of choices, and inside of this list of choices, it has a message, and then you can get its content. So choices of 0, of message, of content. Now this is the final output right there. The capital of France is Paris. So let's create also a convenience function. So get response from messages, but in that case it's not going to be Hugging Face, which is HF. It's going to be OpenAI, and it's going to take in the messages. It's also going to take in the open client, which is the OpenAI client. Let's call it the OpenAI client better. And in here for the temperature, we are going to have temperature. We are going to have it also set to 0. Then we can just copy paste this. So copy paste it. You're going to find that the output for the OpenAI client, and we are going to pass in the messages, pass in the OpenAI client, and then return back output.choices of 0 of message of content, which is the final output. And yeah, this is the convenience function. Let's now take in the messages right there. We can also define a system prompt if we want, but I won't do it here. And it's going to be the same thing. So you can just copy paste it and write, instead of user, you can just write system. We can get the output, get response from OpenAI, give it the OpenAI client, give it the messages, and then print out the output. So right here, the capital of France is Paris. So right now you have two convenience functions to use in the rest of this tutorial. You have the OpenAI client, and you also have the Hugging Face function. I am going to use the Hugging Face function for the rest of the tutorial, but if you want to continue with the OpenAI, feel free to do so. You'll just need to, every time I call this function, you call this function. So it's just, instead of HF at the end, just put underscore OpenAI. Now let's get to the meat of this tutorial, which is creating an MCP from scratch. So let's see how the LLM is going to respond if I asked it, what's my name? So let's create a new section and call it ask what is my name. Of course, the LLM does not know my name, and it doesn't have this information, so we can expect it to respond as such. So let's call it and see how it goes. So right here, I called a messages where the system prompt that you are a helpful AI assistant, and then the second thing is going to be the prompt itself, what's my name? And let's run it and see how it goes. By the way, this is a warning message, so you can ignore it, but the output is right there. I don't have any information about your name, and then it continues on to elaborate that it's an AI assistant and it doesn't know any external information. But if I provided context for this question, it should be able to respond with my name. So let's try to inject my name into the system prompt and see how it goes. So right here, let's provide my name into the system prompt. So you are a helpful AI assistant for a user named Ben. So when the user asked it, what's my name, it should go back to the system prompt and see that the user is named Ben. And you can see here that the LLM responded appropriately. Your name is Ben. This is a super simple and naive example, but what I want to highlight here is that the LLM is able to respond better to questions if we provide context or more information as normal text and append it to the prompt. This is called in-context learning, which is stuffing the model context with relevant information to use for the response. Accessing and exposing relevant data to AI models is one of the 3 capabilities that an MCP provides. It's called the resources capability, and it provides the AI model with relevant data to respond to questions. This data can come from databases, documents, PDFs, local storage, or RAG models. We also have the tools capability. It allows the MCP server to invoke operations on behalf of the AI models. This can be things like sending email, scraping websites, applying for vacations, and way more. The last capability is the prompts, which are reusable LLM messages that optimize an AI's response for specific tasks. Now back to our example, I hard-coded the username into the system prompt and it was able to respond appropriately. Here I only asked about my name, but what if I want to ask about the student's ID, their GPA, their projects, and way more stuff? The LLM might ignore some important parts of the information or hit its context limit, as the LLM can only take a fixed number of words or tokens and does not exceed it. This is especially the case when the pieces of data are long, like the student's project, which might be a couple of pages long. So even if we send the data in the prompt, the LLM might not even process it, given its limited number of input tokens. So we need to selectively choose what data to stuff in the LLM's context when responding to the user. This way, we provide the right data to the LLM when it needs it. So if the user is asking about the name, we append only the name data. And if the user is asking about the GPA, we only append the GPA data. This way, the LLM will have the context it needs to respond to a question without overwhelming or going above the maximum token number. One way to do that is to expose the needed data in functions that return specific information and only call those functions when the user prompt requires it. When the function is called, we can then append this output to the prompt, giving the LLM the context it needs. So we need to have a system that sits between the user prompt and the response generation that can dynamically choose and call one of the multiple functions we have ready for the LLMs when needed. This system needs to carry on 3 tasks. It needs to know what functions are available for use. It needs to determine if the prompt requires the output of one of the tools or functions provided. This is called prompt intent. Lastly, it needs to run the function and append the output to the LLM. Determining which function to run is the hardest part of the system, so let's focus on that. We want to build a dispatcher system, something that takes in the user's request, understands what kind of information it needs, and then choose the right tool or function to fetch that information and give it to the LLM. For example, if the user asks for their GPA, the system calls the getUserGPA function and appends the results to the prompt. Then, the LLM has exactly the context it needs to give a meaningful answer. So for example, if the word GPA is in the user input, we call the getUserGPA function. This works in this case, but there's a problem. Users don't always speak in predictable ways. One user might say, "What's my GPA?" Another might say, "Can you remind me what my grade point average is?" Or even, "How did I do academically last semester?" These are all asking the same thing, but look completely different in text. Rule-based systems like if statements are too brittle for this. They'll miss anything that doesn't exactly match the rules. What we need is something more flexible, something that actually understands language. This is where things get fun. The same LLM we're using to generate responses can also help us understand the prompt because it doesn't only generate text, it understands it. With the correct prompt engineering, we can utilize the LLM as a part of our system to look at the user's message and choose the most appropriate function from our toolbox. The problem of choosing an output from a predefined list of options based on an input is called classification. Let's take a simple example from a different domain to show how this works. Imagine you have a customer support message and you need to forward the incoming to one of those three domains: technical issue, billing inquiry, and general feedback. These three categories form a three-class classification problem. The goal is to read the user's text, then pick exactly one label of the provided labels. This is similar to what we actually want, which is to take the user's input and pick one of the provided functions. This customer support classifier can help us create a system that will forward a user's message to the correct team. For example, if it's a technical support issue, we can automatically forward and send the message to the technical support team. Now let's create this classifier, then jump back to the MCP. Let's create a section for the classification part, and then we can start developing our classifier. So here we have a list of messages, one from the system prompt and one from the user prompt, and basically we are going to call the function that we had to get the output. So the user message here is the customer support message, which is "I love this product," which is general feedback. But for the classifier, I wrote here the system prompt that defines the role of the LLM in this conversation and told it that you are a helpful AI assistant that classifies customer support messages into one of those three categories: technical issue, billing inquiry, and general feedback. This system prompt has an introduction of the task followed by the three categories of the classifier itself. So let's run it and see the response. You can see that the LLM responded, "I would classify your message as general feedback," and then it continues on to elaborate why it chose the general feedback. So we want to send this user message to the general feedback inbox. We can define here a dummy function that takes in the user message and just prints out "send to general feedback." Of course, in the real world, you can write actual code that sends this user message to the correct place. But this is very straightforward to do, so I'm going to keep it as a dummy function like this for simplicity. And I am going to also make functions for the billing inquiry and also for the technical issue. They are also dummy functions, but again, in the real world, you can write whatever logic you want here. Then, to choose which function to run out of those three, we can have something simple like if general feedback, the words general feedback exists in the output, which is this one, then we run send to general feedback. Again, we can have similar if conditions for the other ones as well. So if the billing inquiry is in the output, we send to the billing inquiry. If the technical issue is in the output, we also send to the technical issue. Now let's run it and see the output. So the output here is sent to general feedback, which is from this function. So it saw that general feedback is in the output, and then it triggered the general feedback, send to general feedback function. This works for this use case, but since the output is free generation, it can also be something like out of the technical issue, billing inquiry, and general feedback, the output category is general feedback. Now, if this was the output here, the output here contains all three classes, and basically, it's going to be hard for us to choose which function to choose because all three of them are in the same output. The solution is to make the LLM just output the class name with no extra words or sentences. This is to make the output deterministic so that it can make our lives easier to choose which function to trigger afterwards. So let's create a couple of cells and copy paste our previous prompt. So let's copy paste it right here. Now let's specify how the LLM should output the data. So in here, I specified that the output should be in a JSON format like so, which is going to be curly braces for the JSON, then the key category, and then choose one of the three categories above, which is general feedback, billing, inquiry, or technical issue. So from here, the output is going to be deterministic. We can load it as a JSON, and we can just choose this part. And it will not be free-floating text like this one, so it will be more deterministic for us to choose which function to run. So let's run it and see the output. So the output right here is a string that is showing a JSON output with a key category, and the output is general feedback. So this is now a string. So if you can write the type of the output, it's going to be a string, but we can convert it to a dictionary quite easily using the JSON.loads function and give it the output. And we can put it here in the output JSON variable. And right here, the output is now a dictionary. So if you can write type, you're going to find that it's a dictionary. And basically, if we want to get the general feedback, so we can just do output JSON of category, and the output here is going to be general feedback. This is a deterministic way to have the output, so we can integrate it quite easily with other parts of our code. So instead of having if general feedback is in the output, we can have something like this. So just copy paste it and say if the general feedback is equal to the category output. So you can do the same thing in others. And yeah, when you run it, you also gonna see that send general feedback was also triggered. But we now have simpler if statements where we can just see if the category is equal to general feedback, and then we run the send general feedback function. We can also do the same thing for the other categories as well. Now, those results are more robust and very not prone to errors or bugs or like things that are not expected, because the output is deterministic and we can do very simple if statements like this, and there is no guesswork in that. So this is more robust and better to use. Another way to do this is to put the functions in a JSON where the key is the class name, like this, and the value is going to be the function itself. So we can choose the function to run based on the class name. So if you remember, this has the general feedback. So basically we are getting from this dictionary this function, send general feedback, and then we can call it as if we are calling a normal function. So give it the open bracket, give it the inputs, which is the user message, and then yeah, just run it. You can see that this is a different way to also choose the function to run based on the output. It's very similar to those if statements, but it's in another format, and this format is more integratable with other parts of the code. So I just wanted to show you, and if you are confused about it, feel free to use the if statements. But other than that, I don't think that this is super confusing. It's just a key with a string that has the class name, and the value of it is the function. So basically, this here, you can just replace it with the function name. So what it does is just it replaces it with the function name, which is send general feedback. This is the same thing as that. But instead of if statements, we are choosing it with a dictionary. So in this example, we learned how to make the LLM work as a classifier and how to make it produce deterministic output to be able to integrate with other parts of the code. And lastly, you learned how to trigger those functions based on the LLM output. Those steps are the building blocks of MCPs, and we'll see how we can use this exact same framework to create MCPs that retrieve context data, do tasks, trigger external tools, and way more. So let's recap what our MCP client needs to achieve. The MCP client needs to know what functions are available for use, Determining if the user prompt requires the output of one of those functions, then this is called a prompt intent. Then lastly, run the functions and append its output to the LLM. For determining which function to use, we created this prompt classifier that chooses which function or class the user input belongs to. And we also made the output deterministic to make it easy on ourselves to integrate the output in other parts of the code. For running the appropriate function, which is the last step, we just use the deterministic output to choose which function to run. Now, this prompt has 4 parts. The task introduction, which is the first sentence that introduces the task for the LLM. The list of classes to choose from, the output format, and finally the text to classify. We can now utilize the same prompt structure to build our first MCP client. So let's scroll down and create a new part called MCP development. MCP development. Let's first define the functions or tools that the MCP can use. We will have 2 functions for now, getUsername and getUserAge. Those are 2 very simple functions. The getUsername just returns a string with Ben, and the getUserAge just returns a number that is 28. Now, this is going to be the list of tools for now. They are boring now, but once we have our system ready, we are going to make way more interesting stuff like accessing databases, editing them, and we can also write to files and make a lot of good stuff. And we'll do this all from scratch. So yeah, we'll just start off easy and then build on top of that. So let's run it, and let's also put those functions in a dictionary or a JSON format. So you can see here that this JSON format has the function name, and then it has a description, which is just a sentence describing what this function does. Then a reference to the tool itself, which is getUsername, and then the parameter it takes. And because those functions doesn't take any parameters, I have put none inside of them. Now, this is a very convenient way to put all your functions into one place, and you can refer to them quite easily. And we'll use the description here for the LLM to understand what those functions are for, and we'll use this for the reference like we did here in our functions to get the function and to run it. The parameters are also going to be needed when we have functions with parameters. Yeah, it will be clearer when we have functions with parameters and you see how it's being utilized. But right now, just putting the functions as a JSON format is quite convenient for us, as all the functions going to be in one place so that we can refer to them quite easily. And in the real world, actually, we have this JSON format output that we add to it every function, and the LLM goes and fetches to them. So we'll have a very similar thing when integrating a function with the Claude desktop. And yeah, I'll show you then like the real world. But this is very close to the real world. And yeah, so you just run it right there. And every function we add here, we then go and add it to this dictionary variable called tools. Then let's copy paste our previous classification prompt. So just copy paste this system prompt and come here, add a few more cells, and then paste it. Again, do you remember the 4 parts, which is the introduction, the classes itself, the output format, and then the user input? So the first part is going to be the task introduction. So let's replace that with a task introduction that we can use. And here the task introduction says, you are a system prompt that reads a user message and decides whether to invoke one of the available tools to generate the answer. Now, This is very close to the classification, which is there's a user input and you need to choose one of the tools. Instead of one of the classes, we choose one of the tools. And we defined it right there. And not because every message will require a tool, we need to also tell it that. So not every message requires a tool, only select a tool when it directly helps respond to the user's request. So the second part is the list of classes or tools that we want the LLM to see and utilize. Since we have the tools already available for us in a JSON format, we can actually convert it to a string using the string right there and then write tools. So you can see the output of it, so which is just the tools in a JSON format, get username, it gets the description. Here it tells the function reference. Actually, it won't basically use that, but it will use the parameters, it will use the description, it will use also the function name. So in here, we can just add an F, and we can, instead of listing them down, we can just have like this. So we can have the tools str, which is string, and we can give it the tools, and we can also put it right there. So this will add this tool string into this place of the prompt. Let's also add a title to this section. So the full list of available tools is provided as a JSON here. This is the tools string, and this is very convenient for us because if we added any of the tools right here in the JSON, it automatically will be added here since the tools str is made from this tools JSON, so it will increase here as well. So if anything is edited here, it will also be edited in the tools str. The third part is the output format. In this step, we will also have the JSON output like the one before, but we will make the LLM reason before generating the JSON file. And this is a way to improve the model's ability to respond correctly. This is a prompt engineering technique called chain of thought that makes the model respond more correctly by giving it the ability to think about what it's going to produce. And in a paper that it was introduced for with math equations, it was able to improve the accuracy from 30% to 70% by this simple prompt engineering technique. So let's paste in the output format, and it has 3 steps. The first step is the reasoning step that tells the LLM to reason through what it's thinking before generating the end response. The second part is the JSON output. It's basically a part where I just write the JSON output to know that this is the end of the first part and the start of the second part is going to begin right here. Then the last part is going to be a JSON output like this, and I here have double quotations because this is an F string right now because I'm injecting the tools str, and the way to indicate that this is actually a curly brace and not a thing to inject is to put this double braces. And we can define 2 things, the tool name, so basically export the tool name. Instead, back then we used to have the category. So this is a direct, this is the same thing, the tool name here, then put the name of the tool, then the parameters itself. So if the function takes any parameters, you put it here as a dictionary format. Now, before that, we also need to give the ability for the LLM to tell it if there is no tool needed, then we can simply output a empty dictionary. So this is it. This is basically the output format. First is reasoning. So reason whether any of the provided tools is a good fit or not. Reasoning should be 2 sentences or less. We don't want it to blab on. The third step is to reasoning should end with a new line. No tool is needed if no tool is needed. And we are explicitly saying that if there is no tool needed, just say that there is no tool needed. Then write the JSON output, the words JSON output, and then export a dictionary like with a tool name and parameters. And if there is no tool needed, just export an empty dictionary. The user message here is the fourth part, and here you can write here, what's my name. Actually, like here you can give it whatever user prompt you want, but I am going to give it what's my name. And let's run it and see the response. So here it provided some reasoning first, and then it wrote JSON output, and then it wrote down the JSON format. So it's get username and the parameters are empty. We can then only choose the JSON output by simply having the .split output.split and give it the JSON output, which is this string specifically. And it will divide it into two parts. The part that is the first one, which is reasoning. The second one is the tool name. So the second one is at position 1 and the first one is at position 0. So let's choose position 1 like this. And you can see here that we only chose the JSON part. So you can just print it to see it without those new lines. And this is the JSON part. You can also strip any leading or trailing spaces or indents. So it is not stripped like this, it is .strip like this. And the final part is going to be JSON.loads, and again this is how you load it as a dictionary. So you can have this here, output JSON, and basically this output JSON, you can have output JSON of tool name to get the tool name like that. So this is now working fine, but let's now ask it something that does not require a tool. So basically, what's the capital of France? This doesn't require a tool, and it should respond with Paris, because this information it does have, but this is the client, so it will just only produce what we needed to say. So the system prompt here is defining the LLM's task, which is just classification or tool choice. So it will not respond what's the capital of France, but it will tell us what tools that it will require, and hopefully it will tell us that it doesn't require any tools. So you can see here that the JSON output is an empty dictionary that we actually define to output when we don't require any tools. Last thing before moving forward, let's ask it about my age, and this should take into consideration the getUserAge function. So let's run it and see if it chooses the user age. And indeed, it did choose the user age function, so we are now good to go. The client's brain, the main part of the client, is now working good, and we can now move forward. Now right here, let's wrap up all this functionality into one big function so that we can utilize it easily in the next parts of the code. So right here, I am going to paste in what we already have in the previous sections, but into a function. So this function is called getMessageIntent, and it takes in tools and the user message, and it turns this tools into a string like we did before. I copy pasted the system prompt, and right here I just added one part. Don't number the outputs 1, 2, 3. Right here you can see that sometimes it numbers them. I don't want the numbers. It's just for reasoning. So just remove it. And the last part is to give the messages, run it, and have the output response. So this is the function itself. So just let's also try it out. So get the output right there. We can also give it the tools, and we can also give it the what's my name. And let's run it, and hopefully it will produce the same results as it did. So here it produced the same results as it did by the what's my name. It chose the get username. Maybe the reasoning is a little bit different because I edited the prompt right there, but the final output, what we care about actually, is the same. Now the last step here in the client is to run the get username function and then get its output and append it to the host so that the final response for the user can be generated. So just like what we did previously here, JSON.load, then we split with JSON output, and then we strip it, and then we load it into a JSON. This is what we are going to do here. So it's going to be the same thing. The thing that I added is the lower to make everything lowercase. Just in case the JSON output is lowercase, we will handle that. So this is here the JSON output. We can also see it, so you can just see it right there. This is the tool name, get username, and its parameters. We can then extract the function to run, which is the function name, and we can also extract the parameters. So we can have the JSON output as the tool name, parameters as the parameters, which is going to be an empty dictionary. So let's now run the function. So we will have the tools, and if you remember, the tools here is this part. So this is the tools dictionary that we defined above, way above here. So right here, the tools, we choose the get username and then of tool to get the function reference, and then we can run it by providing the parameters. And when the parameters are in a dictionary format, this is how you provide it in Python. You write ** and then parameters, and it will provide all the parameters it needs. So you can delete this and run this, and you'll find that the output here is Ben. So this is finally the client's output. This is how the client is made. So let's add this function output into a meaningful string so that the LLM can know what ran and what is the output of this run. So right here, I'm going to define just a string. This is the output when we ran. Then I say the function name that does, and then I give it the description, and then the tool output. So this is an F string, and this is how you provide inputs to the F string, but I want to also show you the end output of it. So this is the output when we ran get username. That does this tool returns the, so that does, and then we add this tool returns the user's name, and then the tool's output is Ben. So the last part, let's remember the user message. The user message is what's my name. Let's now add this user output to the user message and make the LLM produce the final response. So the messages here is going to be the user message, so user, and we will have the user message, and we will add a part here that says that the tool's output will be a data output, because some tools will be data output and some tools will be actually tool output. So it's either resources where we return tools, if you we return information and data, if you remember, or tools where functions are being executed. So right now it's only like things data output, which is resources. So I'm going to just write that tools output will be a data output. This information you should incorporate into your answer as factual content. So if it's a data output, you should take this information as factual content and utilize it to produce the output for the user. When you compose your reply, follow these steps. First, inspect the tool's output and weave it into your response. So we're basically saying it that the output of the tool is essential for your response, and then respond appropriately. Use it to directly inform or support your answer. And then we inject also the tool's output. So this is going to be overwriting the user's the user's message by appending this part of a prompt that basically is telling the LLM to take the tool's output into consideration when generating the response. And this is the final part to respond back to the user. So this is going to be the messages. And let's call the function. And let's see the output of it. So print the user. So based on the tool's output, it appears that your name is Ben. So it was able to respond appropriately. So this is the full cycle of the MCP. The MCP now first has the tools, like here, and the tools are in JSON format. Then it goes to the client itself, and the client here determines which tools to run, if any, because sometimes we don't run any tools. Then after getting which tools to run, we actually go ahead and run it. So we load it as a JSON first, and then we run it. And then we return back this part of the, we return back the response to the LLM, which is the host LLM, as a string. So we return it as a string, and then we inject this string to the user's message. And at the very end, we give this edited user's message to the host, and then it produces the final response. And this is the overall flow of the MCP. Now, up next, we are going to put this into classes so that we can make this code reusable and more structured, and it's going to help us also understand it a little bit more. And afterwards, we are going to use it in editing a database, a simulated database, in reading and writing files, and making more interesting tasks. So let's take a look at the MCP architecture again. We saw that the part that connects the external tools to the host is the MCP client, and then the MCP host is responsible to regenerate the end user response and is responsible to also provide the GUI and load the LLM itself. So we are going to make this MCP host and MCP client. So this is our upcoming task. We are going to put it into distinct classes. So yeah, let's do that next. And yeah, to proceed forward, let's define a function called runTools. Basically, what it does is that it here JSON loads, it ran the tool, it then provided the output in a string format. So again, I'm just copy pasted the code, I put it into this. So basically I loaded the JSON, I made sure that it's not empty. If it is, I return an empty string. Then I extracted the function name, the parameters, I ran the function, and then I returned it as a string. Again, I'm breezing over this quite fast just because we already did this. And yeah, this is a convenience function that does all the previous steps in one function. So just run it, and let's now test it. So let's test it and see the output. So this is the correct output, get username, and then it tells the name, which is Ben. So everything here is working good. So we'll make sure to utilize this function when writing our class. So let's define a section called cleanup. And in this cleanup, we will have the classes for the client, and we will have the class for the host. So for the client, you can just write class client, and then we can have an init function. This function runs to initiate the client. We will have the self and the tools, so the list of tools that we are going to use. So we are going to have the self.tools is equal to tools, and the self.tools list str is going to be str of tools. Then what we want to do is we want to get message intent, this function that we defined earlier, and we just want to paste it right here. Make sure that the indent is good. I think the indent here is good. And instead of having this, like making this tools list and making it as input, so just delete it. We already got it in when initiating the client. So right here, I make it self.toolsListStr. This here also takes in self. And yeah, we are now done. This is the get message intent from the client. We also want to copy paste the run tools. So just copy it, paste it right in. Make sure that the indentations are good. Here, I think it's not good. Add the self. And we don't need the tools because we already have it. So message and then message intent. So JSON loads. Everything here is good. I think the only thing that needs to be edited is this self dot tools. And yeah, everything and this self here dot tools. Everything here is now working good. So this is simply going to be our client. The client basically gets the message intent and then runs the tools. And it's going to be like orchestrated by the host. So let's now write the host. So our host is also going to be super simple. It's going to be a class with host. It's going to take in the LLM model. It's going to take in the client itself, which is this client that we already wrote. And it will have a list of the message history. And in here, we will have a function called getUserResponse. It takes in the user message. It takes a copy of the user message and puts it as original user message. What it first does, it runs the client.getMessageIntent. It gets the intent, and then self.client then run the tools. It then runs the tools. It has the tool output. And again, if I remind you, the tools output is already in a string format. Then you can remember that the final part is to edit the user message so that it can have some instructions on how to integrate the tool's output. So this is it also. If the tool output is not empty, basically we are going to define the same prompt that we did above. But instead of having just the data output, we are going to have also a status output, which is going to be the output for a function that does a specific task. So in here, the data output is going to be information you should incorporate into your answer as factual content, but the status output, a message indicating success or failure of a tool for doing an operation. In this case, simply report to the user. Do not suggest or describe how to run this tool because we already ran it. So basically what we need to do, we need to inspect the output. If it's data, weave it into the response, just like we did before. If it's a status message, communicate the status to the user. For the respond appropriately, for the data, use it directly to inform the or support the answer, which what we did before. But for the function status, acknowledge the success or explain the error with offering the tool invocation instructions. Without offering tool invocation instructions, because MCP actually invokes it. So just like we did previously, here when we added this part to the user message, we are going to also add this part to the user message. So the user message is going to add the message.tool, and here is the tool's output already added to the message tool attachment. And what we want to do is that we want to append this to the user history, to the message history. We want to get the response back, to get response from messages Hugging Face. And then the last part is we want to overwrite the previous user's message because we have a lot of unnecessary instructions right there. We will put it as the original user message, and then add the final message from the assistant, which is the assistant message. And assistant message is just the LLM response. because it's the first time that you see that I put the assistant here other than system and user. The assistant here is just the LLM's response. So everything now is working great. So just run both classes, and let's now define our resources and define what functions that we want, and let's test it out. So the functions that we want is going to be the same for now, and we'll add it very soon. So we'll take both the get username and the get user age, and we also take the dictionary format of them, of the tools. So we are going to define resources, which is functions that return back data that the model is going to need into making the response. So we are going to also define the tools dictionary or JSON. Again, this is going to be our tools. And let's now have initiate the client and the host. So the client is not defined. Make sure to run it. Make sure to have it as a capital C. Then scroll down, and in here, just run it again. So the client and the host are now initialized. We can now utilize them to get the output. So let's ask it about, again, my name. So what's my name? It should go invoke the client and then get the output. And then you say your name is Ben. So everything here is working great. We can also ask it about my age. So what's my age? It can go again to the LLM and the client and get my information and say you are 28 years old. So everything now is working great. So as promised, let's make things a little bit more interesting. And we can start by having a function that writes us to a certain file. So let's create a function, define write to file. So instead of you creating a file, you can ask the LLM to create it for you. So you can have the file path and the content. And with open file path, we are going to have it in write mode, and then we are going to write the content of it. We are going to return back a status that says that this file has been written successfully. So right here, file written successfully in the specified path, and we then appended the file path. Now, again, we will need to edit the tools. And after editing the tools, everything else should stay the same. But note here that this function is way more interesting. It will go to your local system and create a file. Now, note that the LLM does not know how to do that. The LLM just generates some text. But with MCPs that you created from scratch, you will be able to go ahead and to write to a file locally in your system. And then you can utilize the same approach to write to databases, to access things, to automate tasks, to send emails. Everything here would stay the same. So you would just add a function, and this function is a tool. So it does a task and it doesn't return back a data. So let's return here the add here the tools JSON. So the tool here name is write to file, and make sure to use the same name here that you have for the function. And you can describe the tool. This tool writes content to a file and then write to file. And here the parameters here become super important. The parameters is going to be the file path, which is the path where the file should be saved, and the content, which is the content that should be written in the file. So just run it and make sure to run the previous one as well. Run this tools and reinitialize the client and the host. And you can also run what's my name and what's my age. It will return the same output, but for time convenience, I will just write a new prompt. So write hello there in a text file in this path, which is greetings.txt. So this will create a file called greetings.txt, and when we open it, we should see hello there. Let's see if this MCP tool works. So just run it and see the results. So the output here is the file greetings.txt has been written to the specified path. The content is hello there. Again, this is a text output from the LLM, but you can go here, you can refresh your folder structure, and then you can see that greetings.txt has been made. So this is now very interesting for us. This is a task that was generated on behalf or like executed on behalf of the LLM, and we know how to do that. And instead of creating files, we can do a lot of things. Just have the description, the file name, and the contents itself. So you're gonna see like this here, this format right there. You can write whatever function you want to access databases, to send emails, to do whatever you want. And just by writing this as a JSON format right there, the MCP host and client will adapt and they'll utilize it quite easily. So if you opened greetings.txt, you'll find that the words hello there is also being put. This is not magic. You are now not, you don't understand it as a black box. You understand it here in detail. You understand how the LLM went ahead and knew what functions to use. It knew how to we wrote the code how to trigger it, and we wrote the code how to incorporate back the results into the user's output. So again, if you're I would recommend you to also go back to your host and to your client and to see what you just did, to see the steps, to see how it does, so that the information that you've gained, you can now like have total clarity about what it does. So this is basically it. This is how you can create an MCP from scratch. Before we close, I want to show you how you can edit stuff, how you can connect to a simulated database, how you can edit it, how you can get data and retrieve data and add data if you want. So basically, I want to show you I want to show you those functions as well. But again, we will be only utilizing those like writing those functions and also writing the JSON for them. Other than that, everything else I will not touch, but we will see right now the awesomeness of MCP and the awesomeness of making things standard so that you can add whatever you want and it will be added very conveniently in a very short period of time. So right now, I am going to paste in some code. So this is going to be our database. It's a simulated database, which is a dictionary. But what I want you to do is that if you want to, you can just connect to an actual database and make those functions actually edit, insert, delete, select, whatever you want. But for simplicity's sake, I'm going to just make it as a JSON so that we can utilize them quite easily and without needing to go outside of this Colab notebook. But again, if you can edit the code inside to connect to a database and do a specific task using the input, then everything else should stay the same. So you can think about this as actually connecting to a database, editing it, and adding it. So this is a student database. The key here is the student ID. We have the name, which is here the Alice. We have GPA 3.2, major computer science, and the enrolled courses right now, Programming 101, Networks, AI, Digital Logic. And then we have another user ID. His name is Bob. The GPA is 3.8. The major is mathematics, and This user takes Programming 101, Math 101, English 101, and Linear Algebra. Basically, I also defined a couple of functions that are very straightforward. So basically, get student GPA. So I take in the student ID. I make sure that the student ID is in this JSON. If it is, I return the GPA attribute. If not, I just return the student not found. Then I have the same thing for get student major. I go to the major attribute and return the major attribute if it exists. If it doesn't, I just return student not found. Same thing for courses, I did here. And all those are retrieval tools and retrieval functions. But let's have a function here to add a student. So this function takes a student ID, student name, student GPA, student major, and student courses, and creates a new JSON for them and adds it to the student database JSON. So it adds this to the JSON, and again, if it is a database, you can just write an insert statement right there. So all you need to do is just edit this part, and this is it. And also another tool is going to be edit student GPA, which is an update statement. And here I just edit the GPA attribute for the student ID with the new GPA, and it takes in the student ID and the new GPA. So it's able to retrieve information, add information, and edit information. And this is the awesomeness of MCPs. Because without that, LLMs are not able to do any of those things. So you can just run it. And the last part is to add those tools into this JSON variable. So for each of the functions below, I am going to add an entry right there. So get student GPA, again, the same name of the function itself, its description, its parameters, the same for the major, the same for the courses, the same for the student, the same for the add student, the same for edit student GPA. So everything here is now set up. Let's run the client and run the host, and let's now have a full run to make sure that everything here is good. So let's run what's my name, what's my age, and writing the greetings file. Let's delete this before it runs it. So yeah, to make sure that it's run. So right here, your name is Ben, you are 28 years old, and let's see if the greetings.txt is generated again, and of course it is. And one extra part here is that the host has the message history, and we can also test this. So let's ask it a question let's ask it a question that doesn't require any tools. So as if you're asking ChatGPT or as if you're asking Claude or anything else, you don't need to specify whether you need tools or not. It will do it for you. So let's ask it, what is the fastest animal on Earth? So let's ask it. So let's do that. Then it knew that no tool was needed, so it didn't trigger any tools. So the fastest animal on Earth is the falcon, and you can see that it says it can reach speeds up to 242 miles per hour. So that is awesome. And the host also has a history of the messages that we have. So I want to also show you this awesome feature. So we can say, how much do they usually weigh? And it will know that we are referring back to the Falcon because it has a history of the messages. So let's run it. And when it's running, I will also tell you the part that does this. So here is the history of the messages. And here we append every user message. And at the end, we append the output of the host or the LLM itself. So if we go back again here, as their weight, falcons typically weigh between 1.5 and 3.5 pounds. So this is awesome. Let's now test the student functions and see if they are working appropriately or not. So let's first ask about the GPA for the student with the ID S001. So the GPA for the student with ID S001 is 3.2. Let's go and check if this is the correct number. So correct. So S001 is 3.2, which is correct. And let's now ask it about the major with student of S002. So the major of the student with ID S002 is mathematics, and if you scrolled up, you can see that it fetched the data correctly, which is mathematics. So let's scroll back down. Let's now edit the GPA of S001 that was 3.2. Let's make it to 3.8. Let's run it and see the results. So the GPA of the student with ID has been updated to 3.8. And you can now make sure that this is the case. So this is the JSON for the students, and you can go to S001 and make sure that their GPA is actually updated to 3.8. So the LLM went ahead and actually updated the database and came back and told us that. But what if I asked it about the GPA of S001 again? Would it go and get it from the database and be 3.8? Well, of course it should be like that because it doesn't cache any data. So it went ahead and to the database again and saw the output, and it was 3.8 this time, and yeah, it was able to do it. So we were able to get the GPA, get the major, edit even the GPA. We can also retrieve it after editing, and it's retrieving the correct GPA as well. So let's now ask it to add a student to the database. So let's add a student with student ID S003. Ben, name is equal to Ben, major is business, GPA is 3.2, courses is English 101 and Business 101. And you can run it and see the output. So the output is telling you that the student has been added, but let's also make sure about that by running the JSON here and seeing if it exists. So S003 exists, and if you go back here, you can see that it only had 2 users, but right now it added it to the list of users. So you can see here that S001, 002, and at the end is 003 has been added. So the LLM now actually added something to the database, edited something to the database, and was able to retrieve even things from the database. And before we close, let's ask it about what's the courses for this. So let's retrieve the courses here for the newly added user and see if it can get it or not. So it was able to get it, and it's telling you that the courses here are for S003 are English 101 and Business 101, which is the ones that we added previously. So congratulations on getting this far. You now know how the MCP works under the hood. You understood a lot about it. You understood about its parts. It's the MCP client, the MCP host, and the MCP servers, how they interact with each other. How can an LLM, which is just a tool that generates text, can also trigger functions, retrieve things from the databases, and do a lot of awesome stuff. You also did that from scratch, so you now know how it works and how we can trigger functions. So congratulations on getting this far. The next step is going to be hands-on practical projects that integrates both a ready-made MCP server in Claude Desktop and a custom MCP server as well. So this is going to be a real-world project where you are using real-world MCPs and creating an MCP servers with the with real-world libraries, so it's not from scratch anymore. And you are integrating it with Claude, which is one of the LLMs that are out there right now, and you can utilize. So this is the next part is going to be very hands-on experience, and it's going to show you MCP servers in practice. So this part right there, you were able to understand MCPs in detail and from scratch, and you opened it up and you saw how it works under the hood, which is awesome. You now have an advantage over other people on that, because not a lot of people understand how MCPs work. They just take it for granted and use MCPs as a tool, but you now understand it from scratch, and this understanding will let you utilize MCPs more correctly, more robustly, and if any problems that you face, you will be more confident and more aware of how to solve it. So congratulations on sticking this far. The next part is going to be more hands-on and more practical, and yeah, see you there. In this part, I'll teach you how you can integrate ready-made MCP servers with your LLM, expanding its capabilities. A lot of companies right now are doing their own MCP servers, and they are providing more and more functionalities to the LLMs. I'll teach you here how you can integrate Decodo's MCP server for web scraping and web crawling, and the process should be super similar with integrating with any other MCP server that you can find on the internet. So with Decodo's MCP server, we can scrape any website that we want. We can even search Google, or we can even search Amazon. Providing the scrape data to LLMs is very useful in practice. A lot of the times when I'm chatting with ChatGPT or any other LLMs, I sometimes even paste in some links so that the LLM can go and summarize it for me, or even take its information into consideration, but ChatGPT doesn't even do that. So Decodo here is providing this feature, so you can just link in whatever URL you want, and it will be scraped, and you can ask it questions about the URL. You can also you can also tell it to take into consideration the information in the website while responding to questions. So it's a very practical tool with a lot of use cases. We'll start by heading to decodo.com, or you can use the link in the description, which will take you straight to the 7-day free trial. This way you can follow along with the tutorial completely for free. Let's now log in. Sign up is really quick, so just log in with your Gmail, or you can register here with an email and password. And yeah, I'll use my Gmail here for convenience, so just click on Gmail. You're presented here with Decodo's dashboard, and once you start using their services, you'll also see here a lot of statistics about your usage right there. You can also view available proxy services and their pricing. At the bottom, you'll find a lot of good documentation and resources that you can read. On the left, you'll find two sections, the proxy section and the scraping section. These are Decodo's core services. Proxy services help you protect your privacy, bypass content restrictions, improve security, and even enhance performance. If you clicked on static residential, for example, you'll find various country options as well as pricing packages that you can choose from quite easily. Now let's go to the scraping APIs, which is what we'll be using in this tutorial. I clicked on the API Playground. This is where you can test Decodo scraping services. There are two options, Core and Advanced. The advanced option supports JavaScript rendering for more complex websites and allows you to choose your own headers. We'll use advanced as it requires for Decodo's MCP to work. So make sure to not select the core. Select the advanced, please. Here you can send a simple post request to Decodo with the URL that you want to scrape. Decodo handles everything, rate limiting, blocking, and retries, all ethically. In this default example, we are trying to crawl the ip.decodo.com. So hit send request. and you'll see the HTML output of the page. You can also press on live preview to display the HTML that you just scraped in a beautiful browser rendering. Let's now try to scrape our own website. So I'll go to a website called NPR, which is a news website. Choose whatever you want. I'm going to choose a random article. I am going to paste it right here in the URL. So just paste it here and then press send request. Now, just like last time, the HTML content of the web page is now being scraped and is being returned fully. You can also press on the live preview, give it a minute, and here it is. This is the page that we just crawled. This is how easy it is to scrape websites with Decodo. You can see it's just a post request to the scraping endpoint and just give it the URL that you want to scrape, and you can paste it right there. Everything else Decodo handles, and yeah, this is very, very convenient to use. You can see that Decodo here is providing the post request that you can copy paste into your terminal, but if you want to utilize it in Node, you can just copy paste this boilerplate code, which is doing again the same post request but in Node. And if you want it in Python, you also have it in Python. So this is the URL that we are hitting to the crawling endpoint, and this is the website that we want to crawl. So for convenience, we can just copy paste it and put it into whatever function or code we want. Now, before we enable the scraper, I want to highlight one of Decodo's awesome features, which is the AI parser. Normally, extracting content from the scrape pages means that we manually inspect the HTML to find the right tags. So, for example, if you are in this news website and you just want to extract the title of it, you need to inspect the HTML and you need to say which tag that you want to get. And you can see here that this is a div. And this is an NA, and this is a div with the wrapper. So you need to specifically choose which part that you want to get to extract the title, for example. And this is basically one of the main reasons that you want to scrape things, is to extract specific information within a web page. But seeing which HTML tags to use is a little bit time consuming, and if you want to have a list of websites, like maybe 100 websites, different websites, you'll need to go to each HTML page and see what divs and HTML tags that you want to choose in each website, for example. And this is going to be tiresome and not very scalable. So with Decodo's AI parser, you simply describe what you want, like the title, article, or image, and it extracts it for you. This makes scraping scalable and fast. No manual inspection of the HTML is needed. So here is a ready-made example that Decodo is providing for us, which is the books-to-scrape.com. You can open it right there. This is books that you can scrape, and it has a price, it has a title, and you can open it. So go back here, we'll scrape this page, so press on scrape. Then again, you have the HTML of it, but you can now simply prompt an AI to extract relevant tags. So get me the title, the URL, and the price of each book listing. And yeah, we don't have to inspect this HTML to know where are they located. We just write it as a prompt right there, and it does the rest. So now it's done, and you can see here the data has been extracted. This is the URL of the book. This is the price of it. This is the title of it, and it is extracted in a beautiful JSON format. The AI parser is one of the awesome features that Decodo is providing right now. Now let's go and enable our free trial. So go back here to pricing. Please again choose the advanced and not the core, since the MCP server needs to have the advanced to work. So go to start with trial enable it, and you'll see the total comes to $0 with 1,000 requests, and you can utilize them within the next 7 days. So this is way more that we are going to need for our tutorial, and the tutorial is going to be completely for free like this. So press on continue to checkout. So finish this really quick process and you will have your scraper enabled. So after finishing, you're gonna find a new tab has been opened for you, which is Web Advanced. So you just click on this Web Advanced, you're gonna see that here is your token, here is your post request that you can actually use to scrape any websites. But for this LLM tutorial, we are going to only need this authentication and the password. So make sure to have those copied, and we are going to use them later on. So moving back to the GitHub with Decodo's MCP server, I am also going to leave this link in the description below. You're going to find that it's telling you that you can claim a free trial, a 7-day free trial. You can also have a quick start, and this quick start here is telling you to go to the web scraping APIs and copy the username and password, which I just showed you. And then basically what you need to do is you need to have the Node.js and the MCP client, which is either Claude Desktop or Cursor. I am going to be using Claude Desktop. So right here you can click on this Claude Desktop, and you can see it goes to claude.ai/download. You have multiple options for download. You have the Windows and you have the Mac. So choose whatever you want. So yeah, press on it. It's going to start downloading. I will pause the video till it finishes downloading, and then I will get back to you. So now it's finished downloading, and installing it should be as straightforward as installing anything else. So just open it, whether you're on Mac or on Windows. This process is going to be just straightforward. You're just going to press next and till it installs. So right here it opened directly. It might tell you to have some installation steps, but basically those installation steps you're going to just have press next, and it's going to finish quite easily. So yeah, it's as simple as that. And here it's just like any other LLM. So you can chat with it and tell it, for example, what's the capital of France? And it's just like any other LLM. It's just going to get it and then say the capital of France is Paris. So you can see here that it's just like ChatGPT. You can just prompt it whatever you want, and it's going to respond. And yeah, let's have a new chat, and then let's see how we can integrate the Decodo's MCP server. So right back to the GitHub repository that we have, it's also telling you to install Node.js. So we can go and write download Node.js. And basically right here, you're going to find a lot of ways to download. You have the Windows. You can also choose Mac. You can choose Linux. You can choose whatever you want. And for Windows, you can just press on the Windows installer. It's going to download here quite fast. And if you are on Linux or you're on a Mac, you can just write sudo apt install Node.js. And right here, sudo apt install. It will then start downloading. I already have it, so after it's downloaded, you can just write node-v to make sure it's downloaded, so you can see here a version. Also, you can just install npm, so you can have sudo apt install npm. Sorry about that, it's npm. I already also have it, so you can have the npm -v. And you can see also here the version. Also, what you can do is that you can download it from the Mac here as a package installer, and you do whatever you want here. Or you can just follow this. You can say that you want it on Linux, Then you can choose NVM or FNM, or you can choose like brew if you want. So you have multiple options to download, so just download in whatever style you want. So back here, you're gonna find that node has been downloaded, so you can just press next, accept, then next, next, and next. Yeah, and then install. So it's basically next, 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 and then install. So basically all you have to do was to press next, next, and then it just installs quite easily. And afterwards, after you finish, you just have the finish button, so just press on it. And yeah, you can go ahead and go to the other steps. So you can see that we need to clone the repository. We need to have the npm install, then npm run build. And yeah, we can do those steps very fast and quite easily right now. So for cloning any repository, you can just download it as a zip file, or you can open GitHub and just write git clone and then clone this. So you can do whatever you want here, but I am going to assume that you maybe don't have any Git, so I will just download it as a zip file. And right here it is zipped, so you can just cut it and paste it in whatever position or whatever folder you want. I will paste it right here. I will then extract it. Again, here it's extracted. So you can, I'm going to rename it and remove this main. So it's going to be Decodo MCP server, and here it's Decodo's MCP server again. Cut this, and I'm going to paste it outside. Just delete this empty folder right now, and then I'm going to rename this as Decodo's MCP server. You can see here that there's some code. We won't need to read any of this code. So yeah, right now what we need to do is we need to open up a command prompt, or if you're in Mac, you can just open up a terminal. And in here, you can just navigate to your folder. So mine is in D, so like this. And in Mac, you can just write CD and whatever like location you want. Mine is in AI videos, videos, and 021 MCP. And afterwards, you can see that we have also the Decodo's MCP server right there. So this is the position of it. And yeah, you can go back again here. You can see that it's telling you to run npm install and then npm run build. So just copy it, paste it right here. Wait for it to finish. While it's running, just copy the run build command. And this is now finished. So like run the run build command. And now it's telling you to cd into build and then run pwd. So cd build. And if you're on Mac or on Linux, you can just write pwd. But right here, I'm on Windows, so you can just write cd. And right here is going to be the location of the Decodo. So from here, what we want to do is that we want to add, right now the MCP server is now set up. What we want to do is we just wanted to link it to Claude. So you can go back here, press on here or the burger icon, press file, press settings, and then press developer. So right here, you're gonna find that it's empty right now, and you say that we have a button called edit config. So you can just press on edit config, and it will take you to this location, and you're gonna see that Claude desktop.json is highlighted, so you can open it. And you can go back here and just copy paste this. So just copy it, paste it right in. And you can go back to your CD here, copy this, and paste it here. So go to your args and just paste it in. And note that in Windows the slashes are the slashes are backslashes, while in Linux and Mac it is forward slashes like this. So it depends, like just copy paste it and everything should be fine. So if you copy paste it from CD if you're in Windows or PWD if you're in Mac, then it should be fine. But if you're in Windows, make sure to have the double back quotations like this. So make sure to have that. And at the end here, make sure to have a back quotations and not front quotations. So this is it. If you save it, it might restructure like this. But yeah, this is the position. Now it's asking you for your username and password. So go back again to your Decodo, copy it, come here, paste it, and paste in your password. Save it, and then you can close it. So after closing it, you also want to close down your Claude. So go again here, File, Exit, and then open it again. Then if you can go to your File, Settings, and then Developer, you're going to find that the Decodo MCP server is now connected and it is running. So yeah, and if you want to also access the config file, you have the button right there, Edit Config. So just close this, and you also want to see the tools. So right here is the tools that are connected, and you're going to see that you have the Decodo MCP here right now, and the tools here are enabled. So scrape as markdown, so this is scraping websites as markdown. This is for Google search, and this is for the Amazon search. We will try them all right now and see if they're working. So one thing I want to show you before proceeding is that if you go to settings and you go to developer and just edit configs, you can open this up and you can see that this JSON file is super familiar to us since we had this hands-on practice, and this is a very similar way to our JSON that we did while developing MCP from scratch. And yeah, you can see here that it has a couple of variables and a couple of arguments and how to run the tool. So yeah, you can see here that this is now super familiar to you. And yeah, you understand how it utilizes this JSON. So you can close this. So now we can proceed on with experimenting with Decodo. So I am going to scrape a website which is going to be utilizing this first tool, scrape as markdown. So you can go back here. I am going to go to a news website called npr.org. I'm going to choose from the business section, and basically you can see this Prime Day offers or something like that. I'm just going to press on it. You're going to see that this is a somewhat of a long article, so you can just ask it what it's about and things like that. So just copy it, copy the link. Don't copy the contents, of course, so you can just have the please scrape this website and paste in the link. And before we continue, make sure that this is enabled. So if it's like this, make sure that they are enabled and press enter. So Decodo here is going to see whether a tool is needed or not, and then it detected that the Decodo MCP tool scrape as markdown is one of the tools that it needs. So you can just press allow once. And you can see here that it scraped the article. It tells you a couple of points inside of it. So it's telling you that this article discusses like Amazon Prime Day, and it's telling you a lot of information about it. And you can also ask it, what is the main 3 points from this article? So basically you can ask it questions about this article, and you can go back and forth with it, and yeah, you now have the full information about this article when you are having this conversation. So this is a very, very helpful way that you can have when chatting with LLMs. It can refer back to the information from this article, or you can ask it to summarize a long article that you just don't want to read, and things like that. This is very useful, and it is awesome. So the next step, I'm going to create a new chat, and I am going to also be playing around with Google search and the Amazon search also as well. So I am going to tell it, can you go to Amazon and tell me how much is an iPhone 16 Pro 256 gigabytes? And this is basically going to go to Amazon and search on it, and then bring me back the prices. So let's also send it and see how it responds. It tells you that Amazon is needed, Amazon search parsed tool is needed, so of course allow it. And you can see here that the request has a query of iPhone 16 Pro 256 gigabytes. And you can see here the actual answers. So you can see here that it is 826 for whatever, the white titanium, and you can see the prices, and yeah, this is awesome. So right now you don't have to go search on Amazon or do anything like that. You can actually have very cool and interesting ways you can search Amazon, and the LLM can help you do that as well. It can also, right now, when it has access to Amazon, it also have the ability for you to recommend you different products depending on your needs, and it will help you with your search when you're looking for any product that you want. Then the last thing is I am going to be experimenting with the Google's search parsed. So let us do that right now. So I am going to tell it, Google me the specs of the Samsung Galaxy S25. And basically, I don't know the Samsung Galaxy S25, and I don't know its specifications. And it is a mobile phone, I know that, but I don't know what specs it has, and what, like for example, the camera, the screen, the RAM, the things like that. And yeah, it's asking you to like use the Google MCP, Google search parsed. So just allow it. We can just wait a little bit for it to Google and return back the results. So right now, it returned back the specifications of the S25. It's telling you that this is a 6.2-inch display. It's telling you the screen specs. And then it's telling you the processor specs. It's telling you the storage. It's telling you the battery. So all good stuff here. And giving those tools to LLMs just expands the horizons of LLMs, and you can actually now know how to integrate whatever tools you want. And with the Decodo's 3 tools, you can now scrape websites, you can Google, you can Amazon search, you can do a lot of good things that you didn't know how to do before. So yeah, congratulations on that. And yeah, basically integrating any other tool should be as easy as that. And the last step here to actually have the full information is how to write an MCP server that you can deploy like this Decodo's MCP server. And it can also be integrated with Claude and things like that. So this is the last thing of the equation before having all the information that you need about MCPs. So yeah, you now know how it functions. You developed it from scratch. You integrated a ready-made MCP with Claude Desktop. And up next is going to be integrating and creating an MCP server that we are going to be integrating with Claude also. So yeah, see you there. Now I'll teach you how to build your own MCP server from scratch. we will build a web scraper MCP server. And in the process, you'll learn how to create an MCP server and connect it to also Claude. And you can also utilize those steps to create whatever MCP server you want. So let's start by installing Python. So if you're on Windows, you need to install Python. If you are on Mac or Linux, I think Python is already installed. So you can just right here install Python, Windows. So just download it, and when you download it here, you're going to also have a .exe file. So you can just open it right here, and yeah, you can just continue on. I have I have Python already installed, so you don't need I don't need to install it again. But installation is straightforward. You just press next, 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 and then you'll be done. So go to your directory that you want to have your project in. You can choose whatever directory you want. I am going to choose this one, and I am going to open up a command prompt, and you can open up a terminal if you are on Mac or Linux. So yeah, you just cd into this, so you can just write your path that you are going to have your folder in. So this is the path that I am going to have my project in. And then afterwards, let's install the required packages for us to create this MCP server. So right here, you can just write pip install MCP. And this is the package that you basically install to create MCP servers. And it's very easy to use. But it also requires a package installer called UV. It's a new package installer in Python that is very convenient to use. And yeah, let's also utilize it. So right here, you can just write pip install UV, search on that. And you can see here that installing UV is just having pip install UV. So come back to your terminal or command prompt or whatever, and just pip install it. And I already have it, so it finished up quite fast, but you can expect it to have like a little bit more time than that. So this is how you install UV basically. Now let's follow up those steps. So right here, it's telling you to initialize the project. So you can have UV in it and then initialize whatever project you want. I'm going to call it Decodo web scraper. So UV init and write Decodo web scraper. You can see here that the project here has been initialized, and if you opened here Decodo's MCP, if you opened the folder, you're gonna find Decodo web scraper, and you can open it right here. So let's open this up with whatever text editor you want or code editor you want. I am going to open up with Visual Studio Code, and yeah, you can see here that this is the main, and yeah, this is it. This is how you initialize a project in UV. So you can go back, first cd into your project. So let's also do that. So cd Decodo, and we called it web scraper. And let's add the MCP CLI. So let's come back and copy our next step, which is the quick start code. This is some boilerplate code that we can utilize quite easily. So just copy it, come back to the main and paste it right in. You can remove those comments. And yeah, you can see here that this is how you define an MCP server. And this is how you define a tool, a resource, and a prompt. Those are the three main things that you can define with tools, like I explained before. And you can see here that it's the same structure. It's basically a decorator function for the tool, for the resource, and for the prompt, and then followed by the function to call if this tool is there. So this is an add function, just adds two numbers. This is a return a greeting function. this returns a greeting. It simulates as if you're returning some data that the LLM doesn't know. And then this is the prompt, and this is like pre-structured prompts specialized for certain tasks, so you can utilize it quite easily. So you can see here that it's just a function, it's just a Python function that takes in some inputs, and you can define whatever input you want, not just those, in the 3 ways, and you can return whatever thing that you want to return. And since all of them are quite the same, we are just going to utilize for now the tool, but it's the same process to utilize the resource or the prompt. And yeah, from here we can name this MCP Decodo website scraper. So you can come here, name it Decodo website scraper. Then we can quite simply go back to Decodo. Right there, make sure that you are on the Web Advanced tab right there. And here you'll find the boilerplate code that we were playing with. We were experimenting with different URLs and things like that. So you can go back to here and press node. You can see that this is the node code to scrape any website, but we want the Python one. So this is the Python code to scrape websites. So just copy it. This is how simple it is. So you can just copy it and paste it right here. So make sure that you have the correct indentations when you paste. This import needs to be at the top, like this. And let's call this function now not add, because it's not adding anymore. It's just getting an article or a text. So let's call it get article text. And it takes in a website URL. And it's a string, and it doesn't take anything else. It just returns a string, which is the article text. Now, a very important step here is to define a docstring. This docstring basically, like in Python, you add it to explain what this function does, what is its input and what is its outputs and things like that. So right here in LLMs and in MCPs specifically, the MCP utilized this docstring to understand what this function does, and yeah, you can write it. You can write it here. So you can write scrapes website HTML and extract the article's text. And for to be specific, you can also specialize. Like you can say that the input is the website URL, the URL that the website to scrape. The output is the text of the content of the article. And yeah, this is it. This is how the LLM will know when to utilize this. And you can see here that the code that we pasted in is utilizing the Decodo's endpoint. It is giving the token that is specific to our users. So this token, when you copy it, it's automatically filled, but you actually can copy it from here. Basic auth token, you can just press on this, and you can see that it's copied to clipboard. And if you want to utilize the code in the in my GitHub repository, so you can just I'll put here a Decodo token, and I'll paste mine here, and in this Decodo token I'll just add it here. So this way, when you come in and if you want to just clone my repository, you can just replace this Decodo token right there, and everything should work fine. So let's call this response crawled article. Now this crawled article is just going to be a response. We need to see if this response was successful or not. And for this case, there is a status code with every response. 200 means that it's successful. 404 means that it was not found. 500 means that there was an error. So basically, I'm just going to check that it is 200. And if it is, I'm going to return the text. If it's not, then I'm just going to say that this website has an error or something like that. So I can have the crawled JSON, which is json.loads, and give it the article.text, and this basically is going to make it as a JSON. So you can here import JSON, and then we can have if actually we can extract the status code first. So status code is going to be equal to the crawl JSON of result of 0 of status code. Then we can say if status code is not equal to 200, then we can say website can be crawled. But if it is, then I am going to get the content of this HTML, which is going to be in the crawled article JSON of result of 0 of content. And yeah, this is basically it. This is now you have the HTML string, but now the HTML string looks like this. So it looks like HTML like that, and it has the body, it has the title, it has a lot of HTML text in it, and with tags, with even JavaScript code. So in order for you to extract only the text of the page, like the actual text in paragraphs and in headers and things like that, we can utilize something called Beautiful Soup. And you can give it the HTML string that has a lot of HTML tags, and it will return just the text inside. So yeah, you can just import it from here, import from BS4, import Beautiful Soup, and yeah, this is it. This is how simple it is to crawl any website of your choosing. Let's scroll up again, and we can see that the website URL is not used. Right here we are scraping the ip.decodo.com, just replace it with the website URL. And yeah, now we are scraping the input website URL. Yeah, that is basically it. That is how simple it is. Then we can just have the if name is equal to main. We are just going to run the MCP. So mcp.run. So this is it. Very simple code. Most of it is copy pasted from Decodo anyways. And yeah. Right now, we need to install requests and Beautiful Soup, as those are not installed. So I'll walk you through them right now. The JSON is already installed, and the fast MCP, we already installed it in the step above right there. So it is the uv.add function. So we are going to utilize the same thing. So come back here to your terminal, write uv add, and then write requests like this. Make sure that it's spelled correctly, and then press enter. So I think I already had it, so it was quite fast. It might take a little bit more time on your end, but that's totally fine. And then the second thing that we want to install is Beautiful Soup. So just right here, pip install Beautiful Soup. Beautiful Soup. And you can see here that in pypy.org, Beautiful Soup here is called Beautiful Soup 4. So just copy it, come here. You can write uv.add Beautiful Soup like this. And yeah, this is basically it. This is how you install both. Also, I had the Beautiful Soup before, so it might take a little bit more time on your end, but that's totally fine. And then we want to run this MCP server. So go back to your Claude. You can exit. So file and then exit your Claude like this. Then we can run our own MCP server. So let's clear our terminal. You don't have to, but just to have a fresh start, we can run uv run mcp install main.py. You can see here it ran, and it's telling me that added the server of the Decodo website scraper to Claude config. Now this is now in Claude config, and it should be working. So this should work now in Linux and also in Mac, but in Windows I noticed that we need to run an additional command that is like very similar to the one above, which is uv.run mcp install -e dot and then run main.py. So run it. You can see also here that it like return the same output. Don't worry, it won't be duplicated. It just will replace it basically. So this is it. This is how you install our MCP server. So go back to your Claude, open it. So right here, you can press on the tools, and you can see that this is the Decodo's MCP server that we were working with before. It has Google search, it has Amazon and things like that. And this is our own custom MCP server. It's called Decodo Website Scraper. And you can see that we called it here Decodo Website Scraper. So this is the name that we gave it here. And it has a get article text, which is the function that we wrote right there. Very convenient to use, and it is, it's live. And to also show you something here, so you can go back to your settings, go back to developer, and you can see here that you have the Decodo MCP and Decodo Website Scraper. Both of them are running. And you can go to edit config, press on Claude desktop JSON. And if you remember here, this was the MCP server from Decodo, and this is now the Decodo Website Scraper that we wrote. So this is it. This is how you run the command, and this is the arguments. And yeah, very convenient to use. So go back here and let's test it out. Like press on new chat, and then let's get an article to crawl. So go back to NPR. And let's choose, like this time, from gaming. So go back to your, let's go to gaming articles, and let's choose this Chess Magnus article. So copy it. If you want to get my exact article, here is the URL. You can just copy paste it. So go back again to your Claude. I would write, please crawl or like scrape this article. I will paste in this and summarize its 3 main points. And yeah, I will run it and let's see the results. It's asking access for the Decodo Website Scraper, which is the tool that we wrote here, the custom MCP server. So let's say allow once. While it's crawling, you can come here and just to make sure that you are utilizing your custom one, you can come to your Decodo ones and disable the tool. So you can disable the tool and to make sure that you're utilizing the correct tool that you want. But you'll find that it's called get article, and it's telling you the Decodo, which is a different name of the tool. So it finished here. It's telling here based on the NPR article about Magnus Carlsen, which is the chess player. It's telling me the 3 different things that it was talking about: historic match ending in a draw, chess 960 format and gameplay structure, and chess growing popularity and skill level. So this is it. And basically for Decodo, you can enable them right there and disable them. And you can also do the same thing for your custom MCP. So congratulations, you were able to write your own MCP server from scratch. You knew how to initialize it. You know that it's very simple right now to write whatever function you can think of, and just add this decorator line, and you now have an MCP tool. This is how simple it is with the fast MCP. You now knew how to scrape websites with Decodo, so also congratulations on that. So yeah, in this video you learned a lot of things. You learned the basics of MCP, you learned what MCPs are, you developed your own MCP framework from scratch. Then we integrated a ready-made MCP, and to finally wrap it up, we developed our own MCP server and also integrated it with Claude. This is awesome work. You learned a lot, and actually you learned all that is to it, to MCPs. So congratulations on that. And yeah, so have an awesome day and see you in the next video.